Hey guys, this is Alan here. I'm going to do a quick how to set up the Ebar system. There's a longer video aside from this one. This one is kind of a quick overview for those of you who already have a pretty good idea of what you're doing. So we've got an Agile 5.5 here. I've already got the servos connected. I'm going to go over that real quickly. So on this helicopter we have what's called an HR3 swash plate. You can look in the Ebar menu and determine what type of swash you have. HR3 is one servo behind the main shaft and two in front in a 120-degree radius. So in that configuration our servos are numbered. So number 1 in the back, then going clockwise 2 and 3. So the Ebar has servo 1, 2, 3, 4 ports. They plug in correspondingly. The tail servo is servo 4. Recommend leaving that unplugged until you've gone into the Ebar and set the proper values for your tail servo as far as frequency, hertz, etc. Okay, so moving on to the next step. After we've got our servos connected to our Ebar, we need to determine whether we're going to use a full-size receiver, a satellite, or I guess it being that an S-bus receiver, a satellite, or a receiver that is not S-bus capable. So here I have an S-bus receiver, a Futaba receiver. You can see it's a very easy connection, just one plug over to the Ebar. If you're using like a Spectrum full-size receiver, we provide you with a 3-into-1 plug. That plug has 3 signal-only connections and 1 plug that plugs into your Ebar also. So it's still a very simple connection. It's aileron, elevator, rudder, signal only on your receiver, and that plugs into the AER channel on your Ebar. You'll also use a jumper from your pitch channel, which is your on a lot of full-size receivers is usually aux1, and that'll plug into the pitch ESC port on the Ebar. Okay. Most of us are plugging our speed controls directly into the receivers. Okay, so moving on from that, let's say we've got our Ebar mounted and we have our receiver connected. One of the first things we need to do now is turn on our equipment. So I'm going to power on my radio here, and I'm going to just plug a battery into my receiver for setup purposes here. Okay, so we're going to open up the Ebar menu. It takes it a minute to initialize, and then we'll get the menu. Okay, so the first item in the menu is bar monitor, and we have mounting. So we're going to immediately just use, right here we have an up and down arrow. You can see if we scroll down, the arrow goes down and up, etc. So I'm going to go down to mounting. The middle button here is enter. Once I've entered there, the bottom selection down there is RX device, which is number 4. I'm going to go down to number 4. Okay, I'm going to click enter, and then my choices are S-bus, KDS JR, and normal. So if you're using a full-size receiver with the AER jumper, you're going to choose normal. If you're using a satellite only, then you choose KDS JR. Now if you're using a satellite only, it's just one satellite capable. It's a DSM-2 satellite, and we don't recommend using that on anything bigger than a 450 because of the one satellite. Okay, so moving on from that, I'm going to select S-bus for mine, hit enter, and while I've got it in this menu, I'm just going to make sure that I've got my parameters right. So the number 1 on here is device orientation. If the wires are facing the back, then you have it rear mounted. So this is rear mounted configuration. If the wires are facing the front, it's front, and then if you have it upside down, it's down rear or down front correspondingly. Okay, so I have mine in the rear orientation, so it's correct. Okay, and then it says rotor direction. On this helicopter it is a clockwise rotor direction. Most are these days, but there could be an exception, so verify that with your model. And like I said, I've chosen an HR3 swash plate. Okay, so now our mounting section is done. I'm going to just click escape, and that'll take us back to the main menu. Okay, so now that we've got everything connected and we have our receiver selection chosen properly and we've connected to our receiver, and just a reminder, I recommend, I'm just using a battery into my receiver right now, but when this helicopter is set up completely, I recommend running a power connection into your receiver and to your Ebar, just for safety. and using a backup battery is a great practice these days with some of the modern choices. So I'm going to power on my system here, and I should get an initialization. It should bounce one time. Okay, good. So that's working properly. So now what we want to do is just move our stick around and make sure that everything's moving correctly. So right moves to the right, left to the left, forward, back is back, and forward is forward. Okay, so that looks good. Now, if it's not moving correctly, generally there's a longer video you can reference, but so I would normally look to see how many servos are moving wrong, if it's one or two. I start by reversing them in my transmitter, aileron, elevator. If it's an exact reverse, if you need to do one or the other, you can go into the servo menu here, which is line 3. So you just scroll down to the servo menu, click enter, and then you'll see the first selection is digital normal servo. It's going to be normally digital these days. Then you have servo 1, servo 2, servo 3 reversing. Okay, 1, 2, 3. So you'll just reverse those as needed till everything's moving the right direction. Now, the next thing you want to check is your compensation. So I'm going to tilt my helicopter. My swash should try to stay flat. Okay, or the servo that I'm tilting towards should go up. Okay, so mine's moving correctly. Now let's assume that when I move the stick, I get right, left, forward, back. But when I tilt it, it moves opposite. That's a quick fix, okay? That just means compensation is reversed. So what you're going to do is you're going to go into the servo menu, and on servo 1, servo 2, and servo 3, make them opposite of what they are currently. So if it's reversed, make it normal. If it's normal, make it reverse. Just go to each one, 1, 2, and 3, and switch them. Then go into your transmitter on your servo reversing and reverse aileron and reverse elevator. Now everything should still be moving the right way, right, left, forward, back, and your compensation should be correct now. Okay, so that's easy. Okay, so now we have our Ebar connected, we have our servos moving in the right direction, and we have our compensation going in the right direction. So now we're going to start with some setup things. I guess we should go over, there may be, some of you guys right now may be saying, okay, my swash plate is initializing, but it's bumping twice. Okay, I'm going to show you how to fix that before we go any further, because if you do it later on, you might have to go back and redo some of your steps. So I'm going to power on my model. Okay, I'm going to wait for the swash to bump. Okay, so mine did it one time, but I'm going to switch it to bouncing twice, and then I'll switch it back with you guys so that you understand how to fix that, okay? Okay, so let's assume that this is your model. You plug it in. And you get 2 bounces. Okay, so what you're going to do is go to line 4. Okay, the controls menu, enter, and you're going to see the first choice there is collective direction. Right now mine says normal. I am going to hit enter. Okay, and then I'm going to change it to reversed and hit enter. Then I'm going to go into my transmitter on the servo reversing menu under pitch, and I'm going to switch it from what it is currently. Okay, so everything should still be moving the correct direction, pitch up, pitch down, but when we plug it in and reinitialize it, now I should get just 1 bounce on the swash plate. Okay, perfect. Moving on from there, the next thing we need to do is put our arms on our servos. Right now we probably have them loosely mounted. You've probably just installed them by hand without screws. That's good. What I want to do now is I want to show you that if your helicopter's sitting here, your gyro is working, right? So moving around is crucial. So what I'm going to do is that in the first line is the bar monitor. I'm going to hit enter. And now in this menu, I basically disabled my gyro and my flight control. Okay? And so that's gonna let your servos sit at a neutral position. Okay, So you're going to just snap on your servo arms as close as you can to center. Okay, and that's pretty simple. And don't tighten them up yet. Just place them on as close as you can get them to center. Okay. Now while you're in this menu, you're going to look at your monitor screen. Okay. Now you see that you have aileron, elevator, rudder, and pitch. Okay, and mine all say 0. Now yours may or may not say 0 right now, but this is one of the most important steps in the setup. So even if they say 0, you still need to follow this process. Okay, so what I'm going to do is I'm going to go into my transmitter and go into the subtrim menu. Okay, and I'm going to start with aileron. Now what I want to do is, regardless of where my number's at, I want to scroll with my scroll in my transmitter on subtrim for aileron. I want to move it until I get, like, let's say that my number is 2, like this one is right now. Okay, then I want to go down until, see if I can do this while you can see it. Okay, I want to go from 0, 1 until it turns to 0. So mine just went to 0. Okay, so I'm going to start counting. That was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so on 13 it moved to -1. So there were 12 steps between 1 and -1. So that means I want to go half of that back, 6 steps to be true 0. Okay? So it doesn't matter what the number is in your transmitter. What matters is that the number is 0 in the Ebar monitor, okay? Because that's teaching your flight controller what your transmitter, or teaching your transmitter what your flight control thinks is 0. So if you don't have this set up properly, you can have drift, your pyro might not be flat, the helicopter won't perform optimally, okay? So it's very important to go down each one of these, aileron, elevator, rudder, pitch, and set up 0, okay? True 0. After you've done that, then you want to go into your travel adjustment and make sure that when you move full deflection, the number changes from 0 to 100. So you'll do that by increasing the endpoint or travel adjustment, increasing or decreasing. Okay? After you've done all of those steps, we'll move on. Now on the pitch setting, I'm going to give you a little tip. The easiest way is to go into your transmitter under the monitor screen and find, like on this radio, we can go to home, and then I believe if I click home again, I'm sorry, over here once, it'll give me a monitor screen, and that'll show me clearly that I can move this stick until, like, it's -15, 11, 8, 3, now I'm at 0, okay? And so I should also have 0 on my pitch, and then I can change my endpoints accordingly. So that's a really good way to get everything calibrated, okay? One of the most important steps. Okay, so here we are, we've just calibrated the radio to the Ebar, or vice versa, okay? And now I'm gonna move my pitch stick back to what it said was 0 on the transmitter, okay? And my servo arm should be 90 degrees, okay? Or as close as you can get them. They may not be perfect at this point. If they are not, the next step is to go back to our servo menu. So I'm going to escape out of here, and I'm going to scroll down to my servo menu, hit enter, and remember we had the first one was digital or normal servos, the next one was servo 1, servo 2, servo 3. The next selection is subtrim for servo 1, servo 2, servo 3. So at this point you'll use the Ebar to program servo 1, servo 2, servo 3 to adjust the subtrim until it's perfect, 90 degrees. Okay? So get that set perfect, and then we'll move on to the next step. Okay? So now that we have that set, our next step is to back out of here, escape, and go to our controls menu. Okay, now this menu is used a lot during setup. So we're in the controls menu, gonna hit enter, and you'll notice that if I scroll down to line 2, it says collective pitch. Okay, what happens at collective pitch, let me show you by moving the swash. So let's say my helicopter's sitting here on the bench like this, and my servos are not square, so I'm gonna go down to the collective pitch setting, and it's gonna lock my swash plate at 0 pitch. Okay, so at this point, you wanna use a swash leveler, drop the swash leveler on your helicopter, and go by and adjust your turnbuckles, okay, until the swash is perfectly level. Okay? You may need to, depending on if you have a swash driver head or a direct link head, you may have to take the head on and off a few times. With a direct link head, the way to adjust your pitch for the most part is going to be by moving your swash plate up and down until you get it pretty close. Then you can adjust the last degree or two with your pitch linkages, okay? But you're going to try to get it as close as you can by moving the swash up and down. So that may mean mount the head, take it off, mount the head, take it off, and the last step should be getting your swash level, okay? So if you have a swash driver head like we're using on this one, it's a little more simple because you can get your swash level and then drop the head on, and you have a turnbuckle linkage on each side of the pitch controls to get the pitch perfect. Okay, so swash is level, perfect. Now what we want to do is mount our head. Okay, we'll do that really quickly. Okay, so head's mounted, and we're using our controller to go to the 0 setting, okay? Collective pitch. So now what we should do is adjust our control linkages. You can use a 4mm open end wrench to adjust your turnbuckles to get it perfect, and you should use a pitch gauge of some sort to mount on your blades and verify that you have 0 pitch. Okay, so normally I use, make sure that my helicopter is mounted securely where it's not moving around. Use a nice level surface on the helicopter to 0 the pitch gauge, and then check pitch with the blades perpendicular to the helicopter. Okay, I always check it on one side, rotate the head, check it again on the same side, and I normally calibrate my pitch gauge multiple times throughout this just to make sure that it's working right. Now, take care and make sure that your blades or your head is perpendicular to the helicopter. Offset by a few degrees can make a difference in pitch settings. Okay, so we should get this set to 0 now. Okay, so after we've done that, our next step is to check plus and minus pitch. Okay, and so what I like to do in this time is I'm on 0 here. I like to, you notice my stick is not doing anything now. I like to move my stick all the way up and then just tab up 1, and that will go to full pitch or wherever you left the stick. Okay, that keeps you from giving it any unnecessary stick inputs. So I've checked this helicopter already. I have 12.5 on the top, and I'm going to move it back down to 0, then move my stick, toggle up again, it's going to give me negative, and I also have 12.5 here. So if you do not, you may need to move your swash plate up or down a little bit. You may need to make a few adjustments in your linkages. What I normally consider close is if I'm within, let's say I get 12.5 up and I have 13.5 down, that's pretty close. We're talking about 1 degree. As long as my 0 pitch was perfectly 0, then what I would do then is go into my endpoint setting on my pitch, and I would adjust the one that was too much to match the one that was smaller, and then I would be set. Now, let's say that you have 11 and 12. Okay, so you adjusted 12 down to 11. Well, you say, oh my gosh, I don't have enough pitch. So that's a simple fix. Right here on this collective pitch setting where I'm at now, okay, the one just above 0, if I add plus or minus, so every 2 clicks is roughly 1 degree. So that's a half degree, a half degree. Okay, so you can very easily, and I'll show you by demonstrating here. So I've hit enter on there this time, and I'm going to hit up. You see it's about 1 degree. 2 clicks, 1 degree. I'm going to go back where I was, okay, and it should be like I had it set previously. Okay, so the important thing about getting 0 set up perfectly and then adjusting your two ranges where you have the same number is that now, let's say you're at the field and you want to add a little bit of pitch, it's very easy to just click here and increase the complete pitch range. So we'll add the same to the top and to the bottom. It's a real nice tool to tune your heli in the field. Okay, so now we've got our pitch range set up and we have our transmitter working 0 is set at 0 pitch. Everything's working like it should. We need to set up our cyclic range. So in order to do that, I turn my head where it's parallel to the tail boom. Okay, and then I take my swash, my pitch gauge, and I will calibrate it perpendicular to the helicopter this time. Normally I do it from the back. You can work from either side. Let's say I do it right here, and then I place it on my blades. When I go down to the cyclic pitch section, which is the, I'm going to go down. Yeah, cyclic travel. Okay, so we have number 2 is collective pitch. Going down 1, it's hard to work from the back of this. Takes us to the 0 setting, and down 1 more, we'll check our cyclic travel. Okay, so it's automatically moving to a certain setting. The manual recommends 8 degrees. That's a good place for everyone to start. I don't recommend going over 9, although we do find that a lot of guys in the 9 range are very happy, up to 9 are very happy with the performance. So anywhere from 8 to 9 depending on your flying style. Okay, so that's an easy thing to check. Now we've set our 0, we've set our maximum and minimum pitch, we've set our cyclic travel. So collective range is good, cyclic range is good. Basically going through a few settings here, you'll see that the next option on here is exponential. Okay, and if I didn't mention on there your cyclic travel, you can just increase or decrease it just like we did on the pitch range. Okay, so going down to exponential, right now it's set at 15. I recommend turning this to 0, and if you feel like you need exponential, use it in your radio. Okay, so scrolling down through the other things, you have pitch acceleration. Most of us run this at 0, but you can increase or decrease this as you desire for personal preference. FB feel is another section here. So this is a kind of a flying style adjustment. It's flybar feel. I'm sorry. Now me personally, I prefer to run this at 0, and I prefer to run my motion setting relatively high because this gives it, the lower this FB feel is, the more kind of locked in your heli will feel, the more robotic, just very, very predictable. As you increase this number, the FB feel is your heli is going to feel looser. So it's just personal preference on how you want the heli to feel. Going on down, we have the NC area, which is your deadband. You don't need to mess with any of those numbers. Okay, so I'm going to escape out of that menu, and we'll go on to the next step. Okay, so here we are. We've just gone through the controls menu. The next option down here is our fly mode. So I'm going to select on that. We have 3 settings for flight performance. You have medium, precise, and vivid. Most everyone is running it in vivid. For 3D stuff. Precise is a nice one to try also. You can play with those and see what your personal preference is. A nice place, bar gain is your swash gain. Default to 75, that will work okay for most helis. I normally start mine in 70 range. That's a good place to start on a 550 to 700 helicopter. I've noticed on a lot of the smaller stuff, the 450s, that you're going to get even lower than that. It just depends on the heli. Okay, this is the motion setting. The next one that I was talking about, I prefer to run this up around 95. But once again, that's going to be tuned to your liking. Okay? So we'll escape out of there and go on to the next section. Okay, so here we are, final stages of the heli setup. We need to make sure that our tail is set up properly and check all of those settings. So I've got my linkages connected. I've gone into my tail adjust menu here, and I've set my servo to the appropriate range, 760, 333 for this particular servo. Check the specs on your servo. Now I can plug in my servo number 4 safely. Okay, so the first thing I'm going to do is check my directions right now. Okay, so I can see that moving my stick, that my direction is reversed right now. Okay, so I'm going to go into my transmitter, and I'm going to reverse my rudder. Okay, so now when I give it left command, it should give it a left movement, and right also right. Okay, so the one thing I want to check, since I did have to do that, like I told you earlier, we need to go back immediately into our monitor screen, and because we reversed it, we need to immediately check our sub trims. Okay, and so we did that earlier. I'm going to back out and do it one more time now because I reversed it. I want to make sure that it's correct. So I go into my rudder and I'm going to move it until I get a 1. Now 0 is 1. Okay, it was 12 points, so I've got 6. So I'm still good. Okay, so I can leave that right at 0 and I'm still perfectly centered. And I've got 100 and 100 movement. Okay, so now I want to check the travel distance in my linkages. It's moving basically perfect right now, but what I'm going to go ahead and go over how to do that. What you would do is you're going to go down to your tail adjust menu, okay, and then you're going to go down to line number 4, which is travel clockwise and travel counterclockwise. Okay, and so you're going to move your stick one direction, and you're going to tab up and down. I was on the wrong one. Okay, so I'm going to tab. See, that moved it more. Okay, so I'm on line 5, travel counterclockwise. I've got my stick held to the left, and I'm going 2 clicks at a time just so that I can see some movement. I'm going 1, 2. Okay, that's coming away from it. 1, 2, away from it. I can actually get a little closer. So I'm going to go back in. 1, 2. I'm going to cycle it both ways. 1, 2. Cycle it both ways. 1, 2. Okay, it's binding there, so I'm going to back out and give it just one more click for safety. Okay, that sounds good there. And I'm going to go enter, move back up to my other direction, move my stick the other way, and go 2 clicks. Okay, it's got close, 2 clicks. Okay, it's binding, so just cycle it to make sure. Come down, 2 clicks. Seems clear there. I'm going to give it just 2 more for safety. Okay, it's very close. Actually, go in 1 more. Okay, and you can see I like to move it over and back just to make sure that everything is settled where it's supposed to be. Okay, so now when you're setting this up, the main thing you can do is you don't need to go and set up a certain degree of offset here or worry about getting this perfectly centered in the beginning. What you need to make sure is that you have the arm, just go into the escape out and go into your monitor screen before you mount your arm, and it's going to just neutralize all your gyros. So you can snap your arm on there at what looks like 90 degrees. Okay? At that point you connect all your linkages, do the setup we just showed, make sure that everything is moving maximum each direction, and then you want to, once you've done that, you should verify that those numbers under tail adjust, clockwise and counterclockwise, should be roughly within 10 of each other. So I have 54 and 62 and within 10 of each other. If I was far spread like 20 or more, then that would probably mean that I either needed to adjust my linkage rod or move my servo arm 1 spline over. Okay, so it's pretty simple. At this point everything should be moving all of the way. Everything looks like it's working perfectly. I'm going to just cycle everything off and on and then check everything once over. Okay, so maybe inside here caused that, but that's a good example. That was not a servo bump like we saw earlier, so I'll need to unplug it and reinitialize it to get that. Maybe I bumped the table while it was setting up. Okay, good initialization there. Move everything over. Looks good there. Looks good there. Let go, everything is staying where it should be. Swash plate is nice and solid. Returning back to 0. Okay, everything looks good. So we're ready to go put a test flight on it now. Okay everyone, so we just finished doing the setup on the tail, and I noticed in reviewing the video that I neglected to mention one important factor. So once you have set up your tail properly, before you call it good, you need to also verify the compensation direction and the tail movement. The way I do that is pretty simple. I give my transmitter stick the command that will move this arm basically as far away from the back or towards the front of the helicopter as possible. Okay, so with your model connected, you're going to just give the input that will move it there. And when you let go of the stick, because you're in like a heading lock mode, the control arm is going to stay where you left it. So I place my finger right there, and I just move the helicopter quickly to the left, and I should feel that rod push on my finger. Okay, if it doesn't push, if it moves away, then it's going the wrong direction. And you'll do just like you did in the other compensation stuff. You'll just reverse the direction in your transmitter and reverse the direction in the Ebar. So switch everything 180 degrees. Just double check your centers again and your endpoints, and you'll be good to go. But always, even after making a switch electronically, go back and physically verify that your settings did take place and that everything's working properly. Okay, hope this helped you guys get through your Ebar setup. Make sure and double check. I may have skipped over when your tail adjust menu. I recommend going and turning your gyro gain to 70 is a good starting point. Yaw rate is the number that it determines the speed of the pirouetting. So if you want it to pirouette faster or slower, increase or decrease that number. Your accel is how fast it accelerates. Exponential, it starts at 50. I normally recommend taking this to 0 and using any expo that you want in your transmitter. Your stop is how hard the heli stops. Obviously you want a nice firm stop without it kicking back, so tune that to your liking. And then your NC area is a dead band. You shouldn't need to mess with that. So now we've gone through all the steps. I hope that makes it easier for you guys. Feel free to hit us up online if you have any questions, okay? And there's a text document attached to this video that you can go through step by step. Enjoy.